Hi, everyone. My name is Stephen Slaughter, and thank you for attending the USGS Landslide Hazards Seminar. This meeting is hosted by the Landslide Hazards Program and co-organized with contributions from Matt Thomas and Jamie Kostelnick. For those of you who are new to this meeting, you can submit questions via the chat window or by using the raise your hand feature in combination with your microphone and video camera. We'll wait until the end of the presentation to take questions. In the meantime, please mute your microphone and turn off your camera during the presentation. Today's speaker is Paul Burgess, who's been with the California Geological Survey since 2018, working as an engineering geologist in the Regional Geologic and Landslide Mapping Program, and currently based in Los Angeles, California. Before joining the survey, Paul worked as a geotechnical engineering consultant in the Los Angeles area after completing graduate studies at UCLA, where he focused on characterizing active tectonics along the northeastern Indian Himalaya front. These days at the California Survey, Paul is involved in a variety of capacities, including 24,000 scale quadrangle landslide inventory mapping, alluvial fan mapping in support of pre-fire modeling of post-fire hazards, working as part of the statewide geotechnical review team for proposed school construction projects, assisting as needed on post-fire survey and response work, and working with his colleagues on the Reported California Landslides Database and web map development. When not doing geology, Paul enjoys hiking with his wife, riding bicycles in the mountains, and surfing. Paul, thank you for being here today, and the virtual stage is yours.
Great. Yeah, no, thanks a lot for the introduction, Stephen, and also, thanks to the whole team of folks that helped put this on, including Matt and Jamie and the whole team. So it's great to be here, and looking forward to sharing some information about what happened in California this last winter storm season. We've had back-to-back storm seasons in California that were some real heavy hitters in terms of the type of impacts that they produced across the state. And in order to get the CGS response mobilized, it's a whole team of people, like it always is, for any good response. And many of those folks here are the co-authors that you can see here on this talk. Lane Young, based in the Sacramento headquarters office of CGS. Kirk Townsend is with me here in Los Angeles. Chris Henningfeld is a student assistant extraordinaire. He's based in Sacramento, currently a student at Cal State, Sacramento. Nina Oakley is in our headquarters. No, sorry, Nina. Nina's in Santa Rosa, hopefully staying cool over by the coast today. Maggie Parks is in Sacramento. And Heather Dean is in Sacramento, and David Slater is also in Sacramento. David Slater is our supervising engineering geologist for the Regional Geologic and Landslides Mapping Program. And to get things started here, we have this really nice photograph of a pretty well-impacted house, basically completely destroyed here in the Hollywood Hills. And this occurred due to activity as a result of shallow landsliding on slopes that are kind of combination of both natural and somewhat altered, at least in terms of some of their foliage in the area behind this home here. So this was a result of some pretty catastrophic rain that occurred in an early February storm event in Los Angeles, and we're going to get into that here in a little bit. So a few other people to acknowledge: Dickie Rigdon, Michael Falsetto, Ray Kang, and Ellie Spangler also provided a lot of support with GIS as well as other mapping products for this effort. Kevin Doherty with some landslide surveying, Dave Longstreth along with Alex Moreland in the Arroyo Seco area of Monterey County. So thanks everybody. To get to an outline of what we'll cover today, we're going to talk about the motivation for this work, CGS mapping products. We're going to talk about the innovations that we have underway currently and ongoing with our Reported California Landslides Database web map. We'll talk about the early February storm that hit Southern California as part of the atmospheric river activity impacting the state over this last storm season. We'll talk about some monitoring across the state, emergency response efforts that CGS is part of, and then also always important to reflect on some goals and some of the lessons, of course, that we learned from this. And so this view here that you see is now another view of that previous photograph of that home. It's more zoomed out. Photos from the LA Times. They had a pretty good drone team out there in the aftermath of this event. And you can see that that slide is coming right off of that slope, of course, right behind that home, those home areas. But also, as I've called out with the yellow text there in the arrow, there's an area of very minimal growth just adjacent to that. And what that is, as far as we can interpret, is some sort of, not too recent slide scar that, similar to this one, that actually activated and destroyed that home. It speaks to the importance of, like any landslide inventory on, whatever scale or, effort that you're putting into it. The more you see, the better, because it helps inform your management and awareness and potential mitigation of hazards before they happen. So when we think about why it is that we really care about landslides in California, and why it is that they matter, most everybody that's on this call here probably has a really good idea about that already. Like any mountainous state, especially one that's riddled with active tectonic processes, from top to bottom, east to west, there are a lot of opportunities for the ground to just be in a state of general instability, one way or another. This is a map sheet on the right-hand side of this image here that dates back to 2011, but it's an oldie, but it's a goodie, because it points out with some of those bright colors, some of the areas in particular in the state that are very prone to landslide risk. And as Ben Maris talked about 2 weeks back, getting down to sorting out what susceptibility is and how to quantify it in ever better ways to do it is just an ongoing iterative process. It involves a lot of feedback between modeling of existing data, but it also fundamentally starts with the type of inventory data that we have for the landslides and where they are. And so in order to think about how we can manage landslide hazard in California, whether it's from seismic hazards, whether it's rainfall induced, and then being able to deal with the attendant costs that come from it in big years, like last year and the year before, with north of $4 billion per year costs sustained across the state, you need to have a good awareness of where landsliding is happening. And so we do that through a variety of mapping products at CGS. This slide shows some general themes in which we create these maps, whether they are hazard maps or risk maps or zone maps. In some ways, many of those map themes kind of work together for some of the different products that we have available that are viewable through our CGS Landslides webpage. It's an excellent jump-off point for really getting into those products. But the main idea is that this is a multi-program effort within CGS, and as you can see here with these different programs listed, we have, the program I'm part of, geologic and landslide mapping. There's seismic hazards. There's forest and watershed geology. There's also burned watershed geohazards, which is one of the more recent groups programs that we have here at CGS. Nina Oakley is part of that. Is our resident meteorologist or geometeorologist, and provides a lot of the feedback, a lot of the analysis that comes into understanding, increasingly the links that come from hazards following fires, and those include landslides, they include debris flows. And together with these other groups, all working together, at any one time, we have a lot of personnel at CGS working on some form of a landslide mapping product or another. And so that speaks to the theme of what we do. We're very interested in making applied geohazard products for the public in California to put to use. And inset on this map here is a nice snip of one of our leading products that we have, this landslide inventory map, or an LSI, as you might hear me refer to it throughout the talk later, just showing a distribution of currently mapped landslides that in many cases are using, older forms of base topographic data. So, a lot of these products are not with LiDAR, so it's been a brand new, age and era to get into that type of analysis moving forward, which improves it. But, these are maps that show where landslides have happened, but as we all know, sometimes you're going to have new landslides show up, and that kind of creates the motivation that arrived at CGS in the 2018, 2019 when I came aboard to start working on a product that we referred to at the time as the Recent Landslides Database. Now it goes by the Reported California Landslides Database, but it's the same concept, which is just that we're trying to increase coverage of landslide hazard awareness across the state by actually mapping where landslide hazards are happening across the state. And in order to do that, we need to keep our eyes and ears open, be outwardly facing, and working with a lot of different sources of data, much of which is crowdsourced, keeping a high level of quality control on where it comes from, and whether it can be vetted or not to include as an event on this database or in it, and then on the associated web map. But it's a really exciting product. It's getting, literally bigger every year as we add more data to it, and we always find new ways to innovate it. And so we're going to get into some of what that tool does and how we use it, why it's important. So as I mentioned a moment ago, this started back in 2019. We currently have data going back as far as 2017. It was the nearest sort of heavy water year in California before that time period. And as you can see here, some of the things that really help this database stand out is the fact that we're really interested in trying to get information about timing of landslides, modes, how they initiate, how landslides may have secondary forms of, movement. We're really, really keen on getting representative photographs that show what happens so that we can publish it on our web map, and then documenting the impacts and doing that, as rigorously as possible so that we can build a robust database of activity that's happening, now or as close to now. If you want to think of now as a geological now, it's recent and it's impactful for people that are affected by it. We have 48 attribute fields on an internal schema that we use to help populate the database events as they get loaded in. I feel like this number changes sometimes from year to year, typically in an upward direction, but we try to, check in with our GIS program people to just make sure that we're staying, within our lane in a sense of what is reasonable and how to portray it on this map, both for us as people, using it internally, but also to think about what's always important, which is the end user, which is the public, or say any one of you on this call, to think about how it's useful for you and how it can be relevant and easy to navigate on a web map. We have a capacity for meteorological data. Not all of the events that are on the map right now have the associated precipitation values. Sometimes it's because there are no precipitation stations that close to where a reported landslide event occurred. Other times we have the data, but it takes a while to work through it. And we'll talk about some ways to improve adding that data into the map towards the end of this talk. And something else that I want to highlight right now that people have asked about in the past and they pointed out, is that there is an inherent amount of bias that is reported with this map. Many of the landslides that are reported here are not too far away from roadways or infrastructure. And part of that is a product of what can be seen or what can be reported upon, especially if you're a crowdsourcing, community scientist member that is eager to share something that you observe. Because unless you can, transmogrify into a hawk and soar over the landscape, which I'm sure we'd all like to do as geologists, it's just, without satellite data, it's harder to see that off the top. Sometimes, like anybody knows here, Google Earth is a great tool. But it depends on the quality of the uploaded image that you can get in terms of surveying, a period of time following a major storm event. We got really lucky with the early February storm because some of that imagery is really high quality. You can task, planet, satellite imagery, or put together other, concentrated, directives for getting satellite photography or imagery for, places of interest across the state, but typically, that process is a little bit more involved because it just takes some time to. Let's see here. Looks like I lost my screen share, so I'm going to just go back. Can everybody see that?
Yep, you're back on again. Thanks.
Yeah, if anybody else is on the call, just make sure to try not to share a screen at the moment, anyway. So, getting back to it though. It takes a little bit of extra effort to get some of that high resolution photography, and we certainly put it to use when we get it, but we definitely try to make sure to do the most with what we can without it. And so all of that leads to a level of situational awareness that creates a really rich database of landslides that are mapped as point features. I know that there's a lot of ways to map a landslide, but what we're really interested in is looking at representative point that can be, really, looked at with great detail on this map app. Let's see here. Somebody else is reporting that they can't see my screen. Can everybody?
Yeah, I can see it fine. And usually what that problem is they need to jump out and jump back in the meeting again. So I recommended that for anyone may have a problem.
Okay. All right.
Sorry about
But
that.
No, it's okay. Can you see it okay? Or do
I can see it great. Yeah, you're still in the Reported California Landslide Database and web map.
Okay. All right. Well, then let's keep charging. And so with all these points that we have across the map, and the way that we get those points mapped, it's basically just like a big combination of effort to get them there. It's, many people on our team doing a lot of QA, QC work, and just basically making sure that if we put a point up on the map, that it is indeed a representative point that's well located with a high degree of accuracy that we can fall back on, so that we have that robust piece of data for anybody trying to use it. And the way that we do that is, we have a lot of different components of how we work on this product. Typically, that's our team of people on the right-hand side of the screen there. These are the folks that are, the co-authors on this talk, as well as with some of our GIS support. And we can also see that, when it comes down to, how we get into, our response efforts as part of our landslide triage team, when there's a big weather event, we're basically on call for most all of it, or as much as the team as a group decides we need to have personnel just trawling the internet for any information that can come through, conventional media, social media. We report up regularly to our state geologist through our senior leadership. So Jeremy Lancaster is our somewhat newly minted state geologist here in California, as the person that is our leader and making sure that he's taking the data that we have to provide situational awareness to all of our responding partners. And then, like any good chain of command or communication, it's, up and down both directions. And so we use the feedback that we get to keep tracking events, following up on photo documentation, and just constantly staying on top of just what it takes to stay on top of situational awareness. And sometimes that involves like providing memorandums, communicating outwardly as necessary. So getting into the next slide here, just clicked over. Let me know when you can. There we go. There's a slight lag. So there's a map here. You can see that this is again now the distribution of all the data that we have on this map across every year of it. When you zoom into it, it of course parses out at a a more local scale. But those events that we log on this map end up getting fed into another product that I'll show next, our dashboard for quick access to information. It constantly informs the way that we're improving the quality of the product that we're mapping. Just basically getting better and more accurate information, sometimes even on return visits to a data trawl for a previously recorded event. And that's important because when we work with partners, whether it's USGS, CHP, California Highway Patrol, Caltrans, that's California Department of Transportation, National Weather Service, we just have all these people that we work with that we're very that it matters much to us to stay in constant contact with them. So this is what this dashboard looks like right now. It's really excellent for situational awareness. Here's a great example of the whole season this last year. You can see there's 627 events at minimum. There's probably going to be some more that we put in here. And a lot of these showed up in Los Angeles County, and part of it is because of a lot of data coming out of LA County. But what you see is that there's coverage across the entire state of California, and not just along the coastal areas. It goes into the Sierras. It goes all up and down and across the state. And that is, a really good observation to the power of this tool by helping track data across the state and doing it very well in real time. So using that data, especially from the situational awareness level, it helps inform places that we think or that we get directed to be thinking about as counties or localities, municipalities within counties that deserve special attention or maybe some mission tasking work. And in order to get that ball rolling and get that project started, or many of those projects started, it has to do with our effectiveness to communicate internally, and then again with California Office of Emergency Services, that's the Governor's Office of Emergency Services. Communications between State Geologist and Cal OES help basically identify and keep an eye on the places that really need help beyond other help they might already be getting. And they might need more and they might not know it. And we're going to get into a couple of examples of some return trips that we took this year, looking at some of these same mission task locations from last year's winter storm season response. So to really start exploring the linkage and also more of the power of this tool in our reported California landslides database, what we need is we need a big storm. And luckily for us and for anybody on this call, including my colleagues, we know that we were working on it. But if you happen to be in California, especially in the southern half of the state, in the first few days of February, you 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 might remember that it was just pretty brutal. And this is a depiction of what that meteorological hammering looks like, as it's this nice image here of the atmospheric river coming into this part of the state. So we're going to get into that in the next few slides here and talk about why that's important to think about the meteorology as it affects the distribution of landslides. So just wanted to take a brief break and get everybody to think about what it might mean when you're thinking about an atmospheric river or any sort of incoming weather pattern of that size and consequence coming at the state of California. Landfall, the duration of an atmospheric river, and knowing what that might look like or how to forecast it is often difficult, even just a few days out, because it's hard to know exactly where the storm or where the bulk of it will ultimately land. So that's why we have this nice picture here of an old shot of Sandy Koufax throwing a great strike, more than likely. And if you're the batter thinking about where to get ready to deal with that pitch coming in, good luck, right? And in some ways, it's obviously more than luck with being ready for an atmospheric river or any sort of storm response in the state. But it still comes down to the same principle of just being ready for a lot of variables to impact how that atmospheric river is actually going to hit. And again, it has to do with effects of orographic precipitation, the orientation of mountain ranges as they're, as they lie with respect to the incoming vectors of the storms, rainfall strength, intensity, how much rain exactly is produced can be very variable. And between the National Weather Service and the Center for Western and Weather Water Extremes, or the CW3E, they have a lot of clues in their tools and briefings, some of which that you'll see here on the next slide, which is an after season look at what happened this year along the West Coast. And you can see actually for California that the vectors or the incoming where the storm was strongest as it approached the coast, which is what these arrows point to. It sort of thins out. It's a little bit more sparse as you move down the coastline towards the southern part of California. But that one red arrow on February 4th really speaks to the strength of that particular storm. And you can see here that a lot of that storm was forecast to arrive, north of Point Conception, kind of Central Coast California. And there were a lot of landslides up there that were produced as a result. There's definitely a lot of flooding all across the area. But a lot of the impacts that we saw with the landslides that occurred as a result of it actually happened a little bit further to the south, in the mountains, especially local to LA. And these photographs here of like before and after, photographs of, what it looks like from a map view of water in the water year. So thinking about how much water relative to a normal or to an average amount of water that would otherwise have, arrived at, that calendar time in the year. You can see the red box calling out the before and after area in Southern California. And notice that over just a few days, basically 3 to 4-ish days, you had this dramatic ramp up in some cases, above 200, probably even in some areas approximating a 300%, increase or 300% of what an otherwise normal amount of water would be. So it's clear we have a lot of water. That's what this looks like on the image to the left here on February 4th, as this atmospheric river system is starting to stall out over Los Angeles County and get into the eastern Santa Monica Mountains. And you see a lot of colorized rainfall, 48-hour precip totals on the image to the right. But as you can see in this next image that's popping up here, this really nice chart just showing the incredible ramp up in the amount of precipitation that was accumulated, as well as the hourly amounts of it as it was coming in that very tight period of time. And this is one chart, but it's a representative graph that basically is mirrored across multiple stations throughout the Santa Monica Mountains. So that's the rainfall, story in a very brief nutshell. Which again, thanks very much for contributing and contextualizing that information for us, Nina, to help get to the next part of this talk, which is this map here, which shows data that we plotted at the time. It should be coming up. in a moment. Looks like there's a brief lag, but you're about to see a colorized map of the state of California that's showing rainfall spikes across the state, and also the attendant black dots that are showing you where landslides were plotted. And in this particular case, we're seeing here that just in that period of time, 253, probably a few more. I say few, probably many dozens more of landslides that we've since added. I know for a fact from that period of time in reporting to present day. You just see the distribution of the landslides, sort of unsurprisingly, lining up where the rainfall totals are. But this is very useful information because it feeds into this situational awareness that we need to make good decisions for emergency response. So to just contextualize it a few more ways in terms of the magnitude of this atmospheric river, incoming precipitation forecasts were saying on the order of maybe 4 to 6 inches or so arriving in the Santa Monica Mountains. The Santa Monica Mountains saw more than a foot of rainfall, especially in some isolated neighborhoods in Beverly Hills area, Beverly Crest, Hollywood Hills. We'll see some locations on a map in a minute, but that is a lot of rain in a very, very short amount of time. San Gabriel Mountains received a lot of rain as well, but the San Gabriel Mountains caught up to the Santa Monica Mountains after a bit of a lag. All of the local mountains with the orientation of those mountain ranges as sort of sub-transverse mountain ranges here in California, they basically just acted like a giant catcher's mitt to collect all of the rain, and not all, but a good bit of it. And so, of course, we see the word bolded here. It's always a shout out to try and remember to think about landslides and not mudslides. But just a brief shout out to the word mudslide is that it's always good to remember to search for that word when you want to collect community reported data, because for better or for worse, the public at large really appreciates the word mudslide. And if you don't search for it or you don't find a way to synthesize a search for that, you're going to miss out on reported slide activity. So a lot of rain fell in the Sierra Nevadas as well. And interestingly, this nugget of rainfall precip data that Nina pointed out to me just yesterday, actually, is that, in this event, Los Angeles, in our downtown location or a downtown weather recording station, saw the second wettest 3-day period since it began record keeping in 1877 at almost 9 inches. So it's pretty big. So changing gears to another map here, just a different version of a previous map that we've seen, but now we're looking at the entire length of the whole season, seeing a similar distribution, but basically we're looking on the order of more than 600 landslides that were reported. There's more than that, sure, that happened, but just with this amount and with the impacts caused from this amount, that was enough to essentially gear up the state for for a request for a presidential disaster declaration, and it was granted in late April, mid to late April. So those types of declarations are important for emergency response across the state, because they recognize the actual significance of these types of events, and they help get funding packaged up and eventually on its way to people that need it to deal with the aftermath. So for us in the triage team and what we do to be on top of what is happening around the state or around the area, we're just you see an example of it right here. We're looking for photographs, we're looking for reports, we're just looking for evidence of what landslides have happened and where, and that's where the hunt begins, especially on a social media trawl, to stay on top of tracking down any and all available data. Sometimes it can be a very exhaustive effort, but that's why it's good to have team members to help share the burden. And everybody that was part of this last winter season knows that there were a lot of long days that were spent tracking down this information. So, we just try to stay on top of it at all times, as close as we can near to the actual impactful storm events, because this data is very perishable. And just like the social media feed, many of you might be aware of, even just the news cycle, even the best and biggest news can become buried rather quickly when more things happen. So you have to get it as soon as you can. And what that means is that, how we respond to that internally, we'd like to start off with basically just building a nice shared PowerPoint slide deck where we just start dumping photographs, as many as are applicable or relevant to certain particular locations as soon as we can find them. And this is a great example here of a really impactful event that happened up in a neighborhood near the crest of the Santa Monica Mountains in Beverly Crest, north of Beverly Hills. And what's kind of cool is that some of you might be able to see here, if you can read the license plate, it says 8 Music 7. So not a shock. There's a lot of very creative license plates here in Los Angeles. If you come down here sometime, you can see. Throw a stone and hit one pretty regularly. But this person actually, or the situation with this particular event is that in the background of that photograph up the hill, you can see a person wearing a bright yellow jacket near that white building. That's a home. The person in that Chevy Tahoe or whatever that SUV is, had just finished dropping some people off from after the end of the Grammy Awards at that White House. And as they backed out of the driveway and they were facing uphill, they got inundated by this wall of debris. So it was very scary for them. They were helped out of the car by some people that lived in another home down the hill, visible to the left of the SUV in the bottom photograph. When Kirk and I went out into the field, we'll get to that in a minute here, to take a look at this. Some of the information that you don't see in a photograph is that timing information that is so valuable that you get from direct field observations or direct interaction with people that were affected in the event. And that's, that capacity to build in that type of data into the reported information for these reported events is yet another one of the features that makes this database a really powerful tool for situational awareness and also being aware of people and how they're being impacted. So speaking about being in the field, you have a nice example here on this map. It's a nice, clean, crisp image that was spun up by our GPP, our GIS and publications program personnel, to help create a GIS field maps app mapping platform, basically an interface that we could use when we're out there, on a phone or on a tablet, just dropping points. It's kind of, it's an updated version of what many of you might be familiar with using with Collector. And similar functionality, you can drop points, you can drop photographs, you can do it very quickly. And it's okay if you don't have any sort of internet connection because you can cache the data and load it up later when you get back. And so what you can see here is over a 2-day time period, pretty good coverage from, some of the only available staff at that time down here to work on this response. All these different locations that are called out on this map are places that we were able to visit. And those field responses are very important for helping contextualize or verify the other reported nature of information that you might not only hear about through a photograph or through a news report up to that point in time. So that nice interplay between doing field work that is well informed with good recon data that you then get to add even more high quality direct observational data to as well. So these are some other images of that location where that SUV was impacted. The photograph on the left, you can see there's kind of a shadow in the middle left of the image, and that's just the area where the car was physically dug out of where it had been inundated. And you see a nice fan of debris coming out on this sort of alluvial fan almost type street geometry. And when you look at the image on the right here, Kirk is observing there's even more inundation further up at the bottom of the hill. But what's really important about this type of observation is that by going out in the field, now you can actually start to take a look at where some of the sources are for these landslides and help identify and distinguish differences between slopes that have been engineered or slopes that are also more natural perhaps, or slopes that have been not impacted by any grading or cut and fill type processes. And one thing that's very important is that in this storm system that impacted all of Southern California, especially the Santa Monica Mountains in and around Los Angeles, there was a really good mix of observed landslide activity that not only happened on altered slopes, but also on unaltered slopes. And that's important because sometimes with the observational bias that we think about with the way that events are reported, of course, most people are going to be, let's just say many people will be, they'll be able to be aware of an event that's destroying a road, but they might miss a bigger landslide that's happening, say, right next to the road on a natural slope. And so, the nature of what they might be reporting may not, truly represent what happened in that area. But the point that I'm trying to make here is that by going out, making observations, you help parse the data and you can improve the quality of the story that it's telling for what happened with the triggering between the rainfall and the landsliding. Another great example of that type of assessment is looking at areas that historically have been well mapped. This fun fact is that on the top center of this map that's in the very center of the screen is where I'm speaking to you from right now. There's an area called the Village Green. It's on some flat ground just north of the Baldwin Hills. And we're looking here at a distribution of landslides in our LSI landslide inventory that were added after some really significant CGS surveying done in 1982 and before that, and cataloged in Special Report 152 from the CGS, which documents really, really beautiful examples of landsliding that impacted the area. But I have this map up here because we're going to flick forward next, and you're going to see the same map. And if you want to just sort of like visually train your eyes so that you can see the difference, right in the center of that map, there's kind of a circular type feature. It's basically the literal center of that map. And that's actually the site of the former Baldwin Hills Dam, which failed in 1963. That's a separate, really cool story. I'll pop a link in for some really gripping video of that into the chat for this meeting later as a side story. But right now it's here in the center of this image so that you can use it as a geographic location point, because when we go forward, you're going to see now the same map, but with our modern mapping interface that we have with our RLD database and field map. And just look at all of these landslides. Many of these landslides that happened in this particular winter storm happened on slopes that have either not seen that level of landslide activity since that 82 storm. Many of them happened on historic surfaces of failure, and you can see that when you go back into that historic report. But just going back and forth, you can see that this is an example of the data that we get sometimes in our published product that will hang around for long periods of time, gets these staggered or these punctuated improvements in its coverage when you have the type of mobilization of field data collection and also just general landslide reporting awareness that you get after these types of big winter storms. And these are a couple of representative photographs of what it looks like. It's a lot of typical shallow surface failures, some slightly deeper seated failures, but mostly just wedges of soil that translated for pretty good distances along locally pretty steep slopes, and in some cases resulted in a lot of red tagged homes or partially inundated homes that were variously assessed by the city of LA. And a side story, this area alone with these more than 160 landslides here, including ones in the oil field off to the left-hand side of this location, where basically a lot of that mapping was done through Google Earth through really high quality imagery following the storms. So when we think about what we do with this type of data and how it matters for what we're getting into across the state, you can see here that there's a lot of public awareness and outreach that goes into creating useful mapping products, some of which has to do with deep-seated landslide activity across the state. This was a map that popped up last year that we were able to put together through a variety of different programs at CGS. And it's outward reporting on that data, and it's putting it into a product that helps people understand where hazards are across the state. It's also one of the reasons that we try to just do the outreach that we can to talk with people, local communities, especially locally impacted communities, if possible, before they might be exposed to some hazards. And this is just a good example of some text from a local publication in Topanga area that saw some inundation events occur. And you see here that they've called out specifically through some correspondence with the chief editor of that publication to just tell people, hey, here's how to contact CGS for this information. This is what they're looking for, and this is why it matters. And so 1 month after this article came out, this landslide happened in Topanga. And if you live out in Topanga, you're always very well aware of natural hazards. There's a lot of fire risk, always. But there's also a lot of landslide risk. It's part of a landslide corridor mapping project that CGS was part of many years back, but it's still relevant. And you can see here that some of the initial reports just show, different forms of this landslide evolving. The first photograph in the middle of the screen here is from March 9th. The second one on the right is from March 10th. Now you skip forward. This is, 6 days later. It's a bigger problem. You can see the location of where this is in our database for events we mapped this year. And you can also see it called out in the inset map on the right, showing that this is an area that has been previously identified as something that's important in terms of hazard. But yet people, our memories are short term, and a lot of folks are not aware of these products. They're not supposed to be. It's okay, but it helps inform our ability to respond strategically and just with the best support that we can provide, which fundamentally is just accurately locating and cataloging this activity within the best of our ability. Because sometimes we get asked to come out, take some site visits, which Caltrans asked us to do, to take a look at, what they were assessing and how they were going about it. Taking a look back at previously issued reports, especially our Caltrans our corridor highway reporting, landslide hazard reporting. And sometimes you end up with some success stories in this case, which is a road opening that happened months ahead of schedule, and basically a nice win for people's awareness without an overly onerous period of impact and disturbance of people's lives. So another example of that is a little bit further north on the way to Ojai, north of the Ventura area. And you can see here that, again, corridor mapping that had been previously performed back in 2016 here is coming into focus again with a really nice example of a deep-seated landslide that happened back on February 22nd. So a lot of documentation on Twitter, and a lot of just really good documentation that goes into our map, which is then coming back into focus with the way that we handle our mission tasking, especially when we get directed to go back to places that we've previously been. So there were 14 mission tasks across the state, California, in last year's winter storm response. We had 2 return visits this year. They're highlighted here on this map, you can see. And when we go back and, when we're out there, it's, being in, clear communication, staying, up to date with emergency response people that are handling business on the ground in these locations is just really paramount. And so thinking about what it means to give good mitigation recommendations for hazards and how to document them, and just how to basically just stay on top of the response in very custom ways, per location, is what's important with these mission tasks. And you can see a nice example of that here. Maggie Parks and Kevin Doherty were out in the field in Madera County, in central Eastern California. And you see these new scarps highlighted in the center of this image that were spotted by a sheriff deputy. So, that's a level of awareness to recognize something that you think might be a hazard, and then to, as the saying goes, if you see something, say something, to report out to people that might be interested in actually helping you understand what that risk is. And that's important because it has to do with previously identified hazards that happened in that area, like this debris flow that was surveyed in the previous winter, just off to the drainage in the right. So these scarps probably happen in the same previous season as last year, but nevertheless, it's a new interest. It's a new concern for people that are impacted. So CGS mobilized and went out there and took a look. Produced some really beautiful mapping here with this nice LiDAR base map. It's a really clearly annotated figure, one of many that show up in this memorandum that was outgoing to Cal OES people and local, authorities that needed to be informed of what was observed and why it mattered. But you can see that this is, one of these themes of the type of mapping that, we take great pride in at CGS, which is creating a very useful map for people that really comes in handy when you need it, and also builds context into understanding, maybe your geologic setting, where you are as a person living in this state, in any of its, very, wildly different, geological terrains at risk for landslide hazards. And in another capacity, this is a great image here. It's another what we like to refer to again as a success story. You can see now the location star on the map is shifted towards the coast in Monterey County. Some of you might have driven right by the slide and not known it was there, because it's kind of hard to, have a neck and a head that high to look out and above the slope. But that's where drones come in handy. And Alex Moreland, thanks to his and thanks to the team with Alex, many different partners at CGS in procurement of many drones, including the Skydio 2 drone that he used to capture this imagery and some of the subsequent imagery. You can see here some really nice examples of course, getting that bird's eye view, like the hawk again, and to just take a look at this and to think on a couple of levels, like, what is this hazard here and what does it mean? there's a very sort of menacing set of scarps in that headscarp zone at the top of that image. There's soil that's cascading down that slope. The rocks and other debris are pelting the roadway below, which is an arterial highway. But there's not much known about what's actually happening. So this happened last year in April, and since that period of time, there's been a very comprehensive effort to monitor and stay on top of what the hazard is here. And so building on that concept of monitoring and identifying what's happening in this location, this is a nice overhead view here, nicely mapped up by Dave Longstreth to help contribute to figures and reporting that's been ongoing with community partners responding to this landslide. And you can see at this image time here in April 26th of last year, there are a lot of unknown components, and so the effort is to get into figuring out what's going on. And the next few slides that we'll get through here briefly just show some of the really beautiful work that Alex and the folks that he's been working with, primarily Alex, put together in terms of analyzing this orthophotography that he's collected with the drone survey and doing analysis on it, including optical image, pixel tracking, pixel correlation to see different parts of where the slope is moving or where it's not. And one of the interesting takeaways with this landslide in particular is that a lot of the slope, the headscarp is not evolving so much as the rest of the slide mass that's highlighted here in this rust brown color in the center continues to move across the slope. And you can see that geometry portrayed in the cross section there on the left. Subsequent image analysis that Alex has performed on this particular landslide also identify areas of landslide volume that's disappearing, or is negative as a red color here, or it's accumulating as a blue color, areas that have been depositing as the slide has been growing. And using a lot of these techniques from structure from motion and building digital surface elevations from the UAV data gets really, really detailed, very nicely detailed capabilities to study this landslide from a variety of angles to just really see what the hazard is and where it is, so that you can really be armed as a community responder or a person living in the community to know what the hazard is. So you can go from thinking, is this whole mountain about to fail, to, well, maybe not, but when I'm driving by it, do I need to be really alert for rockfall and for rockfall associated hazards so that I can get through it and continue along with my life safely. And so ongoing analysis that Alex has performed, another nice survey here showing a vertical difference profile in the downslope direction, completely is also documented with these nice vectors showing the movement down the slope of that slide mass. And all of that is to say is that it's a really nice data set that's been particularly useful for the people impacted by that landslide. It's a great example of the ability for CGS to stand up like a multi-person team on a pretty quick timeline, and to be able to have the through-going consistency and the data analysis and management capabilities to just continue to provide really good products that are applicable and meaningful for people that need them. So reflecting on everything that we've talked about at this point, and with the final couple slides that I have here, just wanted to highlight some of the things that are important to think about in terms of our lessons that we've been learning. We're always up for a good lesson to be learned, like basically everybody on this call. And I'll just go through them here. So QA/QC efforts are really important before, during, and after heavy rainfall events, because they help you improve how it is that you're going to assess and synthesize data for the next storm response. Field work, which we highlighted, is a really important component for characterizing the scope and extent of impacts from landslides. Good GIS support, if you can have it, take all that you can get and say, thank you very kindly for it, and let your people know, because that's absolutely crucial for having a functioning map platform to facilitate your field success. Follow-up communications, checking in with people that have data to share with you, saying thank you, being ready to continue a dialogue is really good for securing more collaboration in the future. And that goes into the last point on this slide, which is like bridge building, and to basically unlock in some cases previous pipelines that were flowing with information back and forth, but that due to years or change in personnel or change in policies sometimes get stopped up. And that's good because then it can help you really capitalize on all that data that you might not be able to collect on your own. And the LA Department of Building and Safety during this last storm season, collected hundreds of data points from landslides, many of which are still internally being QA/QC'd before they can be delivered to us, and then eventually added into this map. I'm hoping to get that data available by the time that we share some of this work at the GSA meeting this year in Anaheim. And then these are just some further developments that I'll leave you all with here. Many of us here love going outside and keeping a track on, where we are in the world, our map patterns and where we're exploring. I'm one of them. I like using Strava. It's fun to just kind of see what's going on and a different way to explore a mountain route that you might not already know. But that photograph is a nice example of just an idea that I checked in with our team here earlier this year. Is like there's a lot of people patrolling around LA or elsewhere, basically wherever you are, taking photographs or on a map. Take photographs if you have landslide data to share and send it to people that can help use it, like us at the survey, for example. But aside from that sort of novelty, the main idea is that we have ongoing data releases and updates that we are always making happen with this database. Updates to that web map are intermittent, sometimes on a quarterly basis. We have another one coming up soon after we get a bit more of this data synthesized from this last storm season. We're always working with our GIS team to just come up with good solutions to figure out how we can do something better or quicker or more efficiently, including coming up with a brand new interface itself for the California Reported Landslides Database. And that's important because it helps stimulate more of a sense of awareness of this data in its long format, in all of its schematic fields that can be packaged up in GIS files for people to work with if they request it from us. And then eventually we'd like to get into just coming up with more ways to enhance the database with meteorological data, and then automating the way that we collect our data to make it even more efficient, especially during really heavy inundation events that just totally stress the workforce of the people responding. So that's all I have for now. Thanks for your attention, and sorry for that one hiccup in there, but hopefully for most everybody it was pretty seamless. And if you have any questions, then go for it.
Hey, Paul, thanks a lot for that talk. We really appreciate it. And it was seamless, I felt like. I'm going to ask a quick question while I wait for other questions to come in. I'm just curious, you showed a few slides ago about landslide monitoring efforts, and I imagine there's numerous active landslides across California. So how does CGS select what landslides to monitor?
So it's really cool because what we do is that we flex all of the the geo Rolodex that we have, which is like checking in with people, including yourself, colleagues at the USGS, folks in different offices that are maybe doing some localized field surveying for data that they're hearing about. But we also try to really outwardly communicate and really extend ourselves to be available for to be ready for action from our community. And this particular slide is a great example of that, because this was not on our radar because of the community person that reported it. They reported it to the city of Los Angeles, which, because of this like freshly germinating, or this rebirth in this communication relationship with them, they actually reached out to us and said, hey, we got this report of this landslide, what can you do about it? Or do you want to go take a look? And so we went out there and took a look. We did our due diligence. We tracked down where the parcel properties were located, what the affected properties, where they were sited. This one at this moment in time is still being essentially like dealt with, or further decisions are being made with the people that actually own this property. But what was really good about us being out there is that we were able to take high quality observations and then have this this documentation of it to show why it matters to be responding to these types of alerts in a timely fashion. And this is actually across the 405 freeway from the Getty Museum, which is to the left of that photograph, out of view. So it's an area that people walk along, but it's also one of those locations that is just kind of, it's pretty quiet. So it speaks volumes that somebody in the community noticed something and then they reported it. So we like to highlight that feedback and what can be accomplished from it.